Hi. I'm going to try something a little bit different with this video. I think it's kind of hard sometimes to just listen to the video when you don't get the same kind of interaction with the teacher that you're used to in class. So we'll see. You can let me know what you think if this is a little bit easier to follow when you can see me, or if it's just weird, which it very well might be. So we shall see. So what I'm going to do is share my screen with you. So here's the notes that we're going to do. And you should be able to see me, there we go, up in the corner here. Make this a little bit smaller. But so this is what you will see. Now I will warn you, when I start using my iPad to write on it, for some reason up in this corner up here, you get kind of a double layered effect. You can see one picture of me that's frozen and then one that's moving. I haven't figured out how to get around that, but at least it still works. So we're only going to do the first 3 examples today, and then you have a big ideas assignment to work on. And what's really cool about this is it's pretty much the exact same thing as what we've been doing. The skills you're going to need, no different. We're still just factoring polynomials. By the way, welcome to my living room. So we are going to look at how we can solve polynomials by factoring. If you remember when we did quadratics, the whole point was that we got it equal to 0, and then we factored and we said if this times this equals 0, then either one quantity is equal to 0 or the other quantity is equal to 0. And so we only had 2 factors in that case, but now as we've seen with polynomials, you might have 3 or 4 factors. But the idea is the same. If you have 4 factors, you set all 4 of the factors equal to 0 and you'll get 4 different solutions. So that is what we're going to try. And so that's this idea here of the 0 product property, which we've done before. So let's look at number 1. So just like all the problems you did on the quiz yesterday, they're not going to be isolated by the type of problem anymore. So you're really going to have to go through kind of mentally that flow chart that we talked about. Looking at, is there a greatest common factor? That's always first. Then you want to look at the number of terms, 2 terms, 3 terms, or 4 terms. And so that's where we're going to go. So let's start looking at number 1. This is where you can probably see 2 of me now, so sorry. So looking at number 1, I have 2x to the third minus 12x squared plus 18x equals 0. So I look for a greatest common factor first, and I see that I can factor out a 2x from each of those. So I'm going to go ahead and do that. Now don't forget here, it's got to be equal to 0, which this one already is. And you need to keep that equals 0 all the time, because now we're working with equations, not just expressions. So when I factor out the 2x, that gives me x squared minus 6x plus 9 equals 0. Don't forget that. And now what's left inside those parentheses there is a quadratic. And so some of you might notice this is a perfect square, but if you don't, that's okay. We look at what multiplies to 9 and adds to negative 6, and you can see right away you're going to get the same thing on both sides. It's minus 3 and minus 3. Now we can write x minus 3 and x minus 3, but it's easier, and we talked about practicing doing this a little bit more. It's a little bit more succinct, a little bit more condensed if we write this as x minus 3 squared. And it's going to be squared because I'm going to get the same factor times itself, and that's equal to 0. So even though that squared stands for 2 factors for a total of 3, I really only have 2 different factors. I have a 2x and I have an x minus 3 that just happens to be repeated. So that's just called a repeated root when we solve. We're going to get the same answer either way, so we only have to solve it one time. But so this is the part where we use the 0 product property. So I have 2 different things I have to worry about here. Either 2x equals 0 or x minus 3 equals 0. So I'm going to get 2 solutions. If I divide 2 on both sides, I get x equals 0. There's 1. And if I add 3 on both sides, I get x equals 3. So there is the other one. And that's it. We're done. So the only new part here, the only thing we've added since taking the quiz yesterday is the stuff in red. Once you get it factored, every single factor is going to give you a solution as long as it has a variable in it. So if we look at number 2, we'll start by looking for a greatest common factor. And while they don't have any x's in common, I can divide them all by 4. So I'm going to do that. I get 4 times x to the 4th minus 10x squared plus 9 equals 0. This is one that is in quadratic form. I know that because I count the number of terms and I see 3. So that's how I know what I want to check. I check the first exponent. I see that it's even. That's my first clue. And then 2 is half of the 4. So now I know that I'm looking at a polynomial that's in quadratic form. So remember, if it's in quadratic form, that means we can factor it just like a normal quadratic. And this is another shortcut, a is equal to 1. I'm going to get -9 and -1 here. Remember, the middle term dictates what your factors start with. So the 4 just comes down, and I get x squared minus 9 and x squared minus 1 equals 0. Now, we've got 3 factors there, but we want to make sure it's factored completely. And so you might be seeing one of them, but you might not realize both of those are differences of squares. This one is x and 3, and this one is x and 1. So I can factor both of those, which means I'm going to get 2 factors and 2 factors for a total of 5. So I bring down the 4. The x squared minus 9 gives me x plus 3 and x minus 3. And then the x squared minus 1 gives me x plus 1 and x minus 1. So that one ended up with a ton of factors. So now when we solve, just a minute ago, I said you get a factor or a solution from every factor that contains a variable. So you'll notice that this first one here, the 4, doesn't have an x on it, so we won't get a solution there, because when does 4 equal 0? It doesn't. It equals 4. So you won't get a solution there. But we can take each one of these where there is an x and set those equal to 0. And you can probably do that in your head. So I'm going to get -3. I'm going to get +3. I'm going to get -1. And I'm going to get +1. So we ended up with 4 solutions, or 4 roots, is what you'll sometimes hear them called. And so that's what we get. Really watch for those differences of squares. We're getting pretty good at that now. I'm really happy to see that yesterday. So fingers crossed. I think we're on a good path here with the factoring. So I'll get you set up on number 3, but what I'd really like for you to do is to take a second to pause it and try to work it out yourself so that you can kind of see if you're on the right track before I let you go here, because this is the last example that we're going to do. So with number 3, what is different from number 1 and number 2 is it's not equal to 0. So that has to be where we start. So our first step is going to be to subtract 14x to the 3rd. And if I'm really keeping it all in order, that's going to go in the middle between the 5th power and the 1st power. So I'm going to move that over here to give myself a little bit more space. So we will end up with 2x to the 5th minus 14x to the 3rd plus, is that a plus? Yeah, plus 24x equals 0. So now from here, you're going to look for a GCF, and then you're going to try to factor what's left. Take just a second, pause the video, and try it yourself so that you can come back and check it. So hopefully you did what I said. So we can factor out a 2x to start. So we'll get 2x times x to the 4th minus 7x squared plus 12 equals 0. This one is in quadratic form. So when you factor that, I'm going to say multiplies to 12, adds to -7. That's -3 and -4. So I get x squared. Remember, we take the middle term. X squared minus 3 and x squared minus 4, all equal to 0. One of those is a difference of squares, so hopefully you caught that. This guy here. So we get 2x times x squared minus 3 times x plus 2, x minus 2 equals 0. Now you might have gotten stuck here trying to figure out how to get a solution from that second factor. We got to dig back to last semester when we learned how to solve quadratic equations. That's going to be one that we can solve by square roots, but there's something really important you got to remember about that. So let's do the ones excuse me, that are easy. So this first one, 2 times what is 0? That has to be 0. This one is going to give us x equals -2, and this one is going to give us x equals +2. So we have to figure out, when does x squared minus 3 equal 0? So we're going to start by adding 3, and I get x squared equals 3. And then we can take the square root of both sides, but don't forget how many solutions that gives you when you do that. Because anytime you add in the square root, remember we get plus or minus the square root of 3. The square root of 3 doesn't come out evenly, so that's why we leave it in its radical form. And so if you really count up what we have, we got 5 different solutions. We got 0, positive square root of 3, negative square root of 3, -2, and +2. So all 4 of those are solutions. If you got something that wasn't factorable further and you couldn't use square roots, you might have to use the quadratic formula. If you do, then you can either look that up in your notes or Google quadratic formula. It'll come right up. Okay, so I'm going to stop this and just tell you a couple things. So you have a big ideas assignment today. So it's going to be 4.5 part 1. That I'll be at school in the morning on Friday, but not in the afternoon. So 6th hour, I'm going to miss you guys. So for both classes, you'll want to get that done so that you don't let your work pile up, because you'll get a new assignment on Friday. But I won't record grades for that until I get back on Monday, after I've seen both classes and we've gone over questions. So that gives you a little bit of time to finish up. Unfortunately, that means I'm going to miss Liberty Hour Thursday and Friday this week. Mrs. Maxon will be there, so you're welcome to come in and hang out. But I don't know how familiar she is with this math. I don't know how much she'll be able to help you with that, but you are welcome to email me. I'm going to be just across the street at Blue Jay Tower both days. Probably a little bit bored in these meetings, so please send me an email, something to distract and something to do. I'll be happy to answer an email from you if you have questions. So please, please, please let me know. I think that we're on a good pace right here, and I have to tell you guys, I'm really impressed with how well you've done with the factoring so far that we've gotten back, and that you're all getting your homework done. You're all staying on top of things. Like I said, if we start off strong, when spring hits and we're all excited to get outside, you'll be in a much better place. So that's all I have for you. You can reach me by email, and I will see you guys on Tuesday when we get back to school next week.